removed, NaCl is removed, and these two are connected here. So the product like this: CH3, CH2, CH2, CH3. This is the product we are going to get. It is called what? Butane. It is called what? Butane here. You can take different products also. Here you can take different. Here also you can take different also. So now which halogen carbon we have to bond here? Halogen bonded carbon. This is the halogen bond carbon, and this one is the halogen bonded carbon. Both will be bonded like this. Okay. Now let me see now here some important points about this Wurtz reaction. Already we studied in the 11th class. Let me see again this one also. Now in this case what happened? Methane cannot be prepared by Wurtz reaction. Is it possible? Methane impossible, because if I take what happened, methyl chloride, what is the product we are going to get? Ethane we are going to get, right? Correct or not? That means if I take one carbon, they are converting into here what? Two carbons. If I take here what? Two carbons, it is converting into what? Four carbons. That means it is getting double now. Understood or not? That is the reason what happened. Methane cannot be prepared by what actually? Wurtz reaction. It is impossible to get the Wurtz reaction. And symmetrical alkane is major product in the Wurtz reaction. Now what is the meaning of symmetrical alkane? Let me see now with an example. Let me see with an example. Isn't it? CH3 chlorine. Isn't it? Reacting with sodium plus. Isn't it? Again what happened? One more sodium I am taking here. Chlorine, CH2, CH3. So this is called methyl chloride. This is called what? Ethyl chloride. Now what I am doing here? NaCl. NaCl. Here I am removing NaCl. Here I am removing it. So when you join these two, what happened? CH3, CH2, CH3. Propane is forming. Here one carbon. Here how many carbons total? Two carbons will join here to give propane. But there is a chance of what? Having like this also. CH3, Cl plus sodium. Again the sodium plus Cl, CH2, CH3. Now here NaCl is removed and here NaCl is removed. So we are going to get what happened? CH3, CH2, just a minute. Same thing I have taken. Now I will take what happened? Same thing I will take. CH3Cl. Same thing I have taken. So what we are going to get here? What is the name of the product here? Tell me. Ethane we are getting actually. We are getting what here? Ethane. CH3, CH3. If I take only these, this is the thing. Chloroethane. So CH3, CH2, Cl. Again with sodium. Second sodium. Again what happened? Chloroethane. Cl, CH2, CH3. So what we are going to get? NaCl. NaCl is removed. So here CH3, CH2, CH2, CH3. That means if I take, okay, chloromethane and ethyl chloride or chloroethane, how many products are maybe possible? How many products are maybe possible? If I take chloromethane and chloroethane, how many types of products will be possible? One is butane is possible, other is propane is possible, and next what happened? Ethane is also possible. So we will get what happened? 3 products we are going to get, isn't it? So this is the reason what happened. Wurtz reaction is not suitable for odd number of carbons. It is what? Suitable for even number of carbons. Even number of carbons when we get here, when you get, then generally when you get same what happened, we'll get the even number. Okay. So here symmetrical alkane is the major product for what? Wurtz reaction. Symmetrical means what happens? Same alkanes. If we get what happened, that will be the major product. Different will get, isn't it? See, this is what different or not? Different or not? So here we are going to get the different types of products. Okay, if I take what same like this, then only what happened? The products will be get same type of products here. So this is the meaning of this one. Now, one more thing, if I say what happened, if I in the place of sodium, if I take zinc, then the reaction name will be changed here. The name of the reaction will be Franklin reaction. So what is Franklin reaction? It is also same like Wurtz reaction, but the metal they have taken is what here? Sodium metal. Therefore, that is called what? Franklin reaction here. Next, what happened? The Wurtz reaction, if you observe what happened, same thing what we are discussing, everything. See this one. So we discussed this one. Now one more thing, we have taken dry ether. So why we are taking dry ether? Because sodium isn't it, highly reactive towards the moisture. If sodium reacts with moisture, what happened? Moist ether, if you take what happened, it will contain some water content in this one. So it will react with water to form sodium hydroxide here. In that case, Rx will react with sodium hydroxide to give your what? Alcohol. It will give your what? Alcohol, isn't it? Understood here? Alkyl halides, when react with moisture ether in presence of sodium, you are going to get alcohols, but not what? Alkanes. So that is the reason, to prevent this reaction, what we have to take here? Dry ether we need to take. If they ask in examination, you have to give answer like this. So this is examples we have taken actually. So what is the product here? Tell me. The name of the product will be butane. It is. Now, see here, we have taken one is methyl bromide, other is I have taken ethyl bromide. Now, in this case, we get actually different number of alkanes we get here. It is not a suitable method for us. So, different number of alkanes. Already we have studied this one. We got ethane, we got actually what? Minor product, what happened? Propane, other is called what happened? Butane. In this way, you are going to get, isn't it? Three types of products we are going to get. Now, which one is major in this case? Whichever is what? Symmetrical is major. Now, which one is symmetrical here? See, this is symmetrical. You can cut into equal parts. This is symmetrical. That means methyl bromide, if it react with methyl bromide, you are going to get ethane, or ethyl bromide, if they react, what happens? We are going to get butane. But mixing these two, what happened? Different carbons. Having two carbons and one carbon, that will be always what happened? Minor. Already we discussed this one, but this is shown in the slide like this here, in which what happened, isn't it? Same carbons, when they bind, they will be major. Different carbons, if they bind like this, what happened? Here it is seen. One carbon and two carbon, that will be always what happened? Minor product here. Next, what happened? Reaction with metals. When alkyl halides react with metal, what happened? We get a famous reagent called grignard reagent we are going to get here, isn't it? So the famous reagent called grignard reagent, RMGX, we are going to get. This is called what? Grignard reagent, isn't it? So this is definitely we are going to get here. When you treat with what? Metal. See, alkyl halide reacting with magnesium. So we are going to, this is also in presence of dry ether. Why? Because magnesium will react with what? Moisture to give magnesium hydroxide. That is the reason what happened? Take dry ether, which is not having any water content in this one. So I have taken here dry ether. So we are going to get addition reaction. Now magnesium will take the position between the alkyl and halogen like this. This is called what actually? Grignard reagent. Now which metal is present in the Grignard reagent? Tell me. Which metal? Magnesium is present, isn't it? Now if you observe here what happened, in this case, this R is getting negative character. This R is getting negative character, which is very, very important for us. Where magnesium will get, obviously what happened? metal will get positive character and R, carbon, will get the negative character. There is a use of this one. So alkyl magnesium halides are nothing but called, isn't it, organometallic compound. What is the meaning of organometallic compound? Organo means carbon chain. Metallic means what happened? Magnesium compound. Organometallic compounds here. We'll see some example here, isn't it? We'll see some examples here. Like, if I take what happens, CH3Br, okay, reacting with magnesium, what is the product? If I take what happens, CS3CH2Cl, in presence of magnesium, dry ether. Here also what happened? Dry ether. Now write down the products for this one, your notebook. All of you take exercise this one. Methyl bromide on reacting with magnesium in presence of dry ether. Ethyl chloride on reacting with magnesium in presence of dry ether. What are the products we are going to get here? Here also what happened? I have taken bromine. Now treating in presence of magnesium, dry ether. Now write down the products here. Okay, your notebook, all of you write down the products. Have you copied this one?
Yes, sir.
Just you copy this: methyl bromide, ethyl chloride, bromobenzene. Remaining are common, no? So no need to practice, no need to copy this one. Easily now you can take now: methyl bromide, ethyl chloride, bromobenzene. So write down the products in your notebook and you have to send on Google Classroom today itself, not tomorrow, today itself after the class. Right. Next we'll see some note. Shall I take ether only? No, you can take even what any solvent like THF, you can take THF called what? Tetrahydrofuran, or insol also we can take for the preparation of grignard reagent. That is not very important for us. Now tell me the answer for this one, all of you, do fast. What will be the answer now here? What is the R they are asking? If it is butane, what is the R? Now tell me which reaction it is?
Wurtz reaction.
Now tell me the R means what it is. What is the meaning of this reactant? Which is the reactant? Now tell me. Do fast.
Ethyl chloride.
Ethyl chloride. D is the correct option. Why? Because this is the 2 carbons are there. Now 2 carbons will convert into 4 carbons. Now definitely we are going to get the butane. If I take 1 carbon, we get here how many? 2 carbon. That will be ethane. If you take methyl chloride, what is the name you are going to get? Ethane. Now if I take this one, what is the product we are going to get? Let me see this one also. CS3, CH, CS3, Cl. In this way you have to write like this. This C1 I am writing here. C I am writing, you observe here. C I am writing like this. Now this is again reacted with sodium. Again reacted with sodium. Now take reversely this one. CH, CS3, CS3. Now remove the NaCl. Remove the NaCl. 2 carbons will be bonded here. So we are going to get here CH3, CH3, CH3. This is the product we are going to get. This is called 2,3 dimethyl butane. 2,3 dimethyl butane. 1, 2, 3, 4. 2,3 dimethyl butane. Isn't it? Isobutyl chloride, same it is, same. Both are this one is what? Isobutyl chloride also same like that you will get. CH, CS3, CH2, Cl. This is called what? Isobutyl chloride. Isobutyl chloride. You can also write this for this one also product. Very simple, by joining here. Remove this one, same thing you can join here. In that case, you will get here CH3, CH, CH2, again same thing will be joined. CH2, CH3, and again what happened? CH3. This is the product we are going to get. 2, 1, 2, 3, 4, 5, 6. 2, 5 dimethyl hexane we are going to get here. So all of you write down the products for these 4 options here. Okay, I have written here isobutyl chloride. I have written here what? Isopropyl chloride. This is the isopropyl chloride, and this one is the butyl chloride. All of you write down these in your notebook and submit today only. I think this will be easy for you. Tell me the answer.
Magnesium.
Magnesium.
Generally, the reaction takes place in this way. Rx when treated with magnesium, we are going to get like this. CS, you can take even iodine also. Bromine, X place you can take chlorine, bromine, or you can take iodine here. Okay, in this way, we are going to get the grignard reagent. By adding this magnesium where we are actually, isn't it? The best grignard reagent. Generally, what happens if I take iodine, that will be the best one because you can easily cleavable it. It should be cleavable here. You can take one bromine also there. You see, you can take one bromine also. What we get here? Magnesium will shift here like this. Okay. Definitely, what happens? Symmetrical alkenes we are going to get generally. Now you take this one, action of alcoholic potash with isopropyl bromide. Just now I explained this one. Just now I explained this. Alcoholic potash it is. Alcoholic potash. Okay, you try this one. Alcoholic potassium reacting with isopropyl bromide. You will get the propane. Try this one. Now here very important thing. When grignard reagent reacts with water. Yes, just a minute, sir. Wait just 1 minute. So RNGX reacting with water. Okay. Now what happens here? From this H plus will be, isn't it? You are going to get RH. RH we are going to get. Okay. For example, if I take CH3 MgBr, when you treat with water, okay, from water you take H plus and add to what CH3, that will convert into what here? CH4 here. So this I will explain here in next class. Why? Because all are giving methane only. You see what happened. All are will giving methane. Why? Because add your hydrogen, methane you are going to get. Add your hydrogen, methane. Add your hydrogen, you will get the methane. In all the cases, what happened? You are going to get the methane only, right? So this is about the Grignard reaction. So alcoholic potassium with 2-chlorobutane, already we have discussed this one. So definitely it will be 2-butane. Already we discussed this one. Next part we'll discuss in the next class. Okay. So this is about today's